Hello, my name is David Ackerman, student number 220-310-629, and this is the MEC 2302 assignment 8 for dynamics. This is the question that we're given at hand, where this is the diagram, or this is the diagram we were given. This is the question with all the given values, and these is what it is required for us to do. So here are the givens where we're given the mass of the bucket, the mass of the reel, the radius of the reel, the radius of gyration, the distance fallen, the distance which is a height of 2, and then the initial velocity is 0. So we're asking to find the velocity of the bucket. We're just naming it v. This is the diagram right here. And the analysis where we just have to literally use the conservation of energy, and that is all that is required, where it's adding up the energy of the initial equals to the energies of the final, where it's the potential energy of the bucket, the bucket lost equals the kinetic energy of the bucket plus the rotational energy of the wheel, which is literally just mass of the bucket, gravity, height for the potential energy for the bucket half, oh, sorry, half half mass to bucket velocity squared, which is this is the velocity that we're going to be looking for. The half of the mass of the rate, the real times the Ka squared, which is the w, and then W squared or omega squared, which we're substituting for V divided by R, and then we're plugging that in here. We're subbing in all the known values in here, and here we're solving for them. So if we solve for this, it's going to be 981, and here we're solving for in terms of V. We're adding V, and then here we're isolating for V, and here we get that velocity is 4.05, right? So if we were to look at the question, determine the velocity of the bucket hitting the water at the surface, the velocity would be 4.05 meters per second. Now, question B is how can we make it a little bit safer? So, in order to reduce the velocity at which the bucket falls without changing the design of the bucket itself, and it can modify certain aspects of the pulley system. One effective approach would be the increase of the mass of the reel. A heavier reel means that the rotational inertia, meaning that the greater potential energy of the system, would go into the rotating of the reel rather than accelerating the bucket, thus reducing the bucket's final velocity. Another option is to increase the reel's radius of gyration, which would also increase the moment of inertia and further diverts the energy of the rotation of the motion, which would then decrease the velocity. Lastly, the decrease of the radius of the wheel, decrease the radius of the wheel would increase the angular velocity at any given linear speed, thereby increasing the rotational energy and reducing the bucket speed. Any of these changes would result in the bucket descending lower, meaning that the velocity would be lower, according to the equation that we're given here for um, conservation of energy, and making the system safer and easier to control by the users in Anna's community. This has been all my work. Thank you so much for listening.